Hi everybody. Today I am going to just give you some introduction about the electromagnetic theory and what are the various necessities and various applications in the particular electromagnetic fields in the engineering domain that we are going to discuss about the objectives and the syllabus and outcome we are going to discuss it today. Then the objectives to introduce the basic mathematical concept related to the electromagnetic vector fields. It means the very fundamental mathematical concept, the vector additions and subtraction, multiplications, dot product, cross product, and the differentiations and integrations, Stokes theorems and divergence theorem. Based on that, we are going to discuss it. That is the first objective. The second one, to impart knowledge on the concept of electrostatics. The electrostatics means the energy stored in the form of electrostatic, that is the capacitance. Then the electric potential and the energy density and its applications we are going to discuss in the case of electrostatics. Then the third objective, to impact knowledge on the concept of magnetostatics. It means the inductance, the energy stored in the form of magnetostatics. Then magnetic flux density, scalar and vector potential and its applications we are going to discuss. Then the fourth one, the input knowledge on the concept of Faraday's laws and induced EMF and Maxwell's equations we are going to discuss in the fourth unit. That is the fourth object. Then the last one, to impact knowledge on the concepts of electromagnetic waves and the pointing vectors. Then the while we are comparing this all the objectives, the first one is the basic, the second one is the electrostatics, and the third one is the magnetostatics. Then the fourth one is the electromagnetic applications. Then the fifth one is the magnetic waves, that is the purely applications oriented based on these four objectives. First four objectives, the fifth one has been derived. And unit 1, that's the sources and effects of electromagnetic fields. What are the various sources are available? Then what is the effects in the electromagnetic fields? Then what are the various coordinate systems are available? The cylindrical, the rectangular, and the last one is the spherical. That uh, while we are concentrating these coordinate systems, how it is behaves, then corresponding vector fields, potential gradient, divergence and curls, and theorems and applications. Here we are going to discuss Stokes and divergence theorems, and the Coulomb's law, and electric field intensity, then electric field due to discrete and continuous charges, and based on the charges the Gauss law was developed. The Gauss law based applications to find the electric field intensity and electric flux density, etc. The continuation of the first unit, the electrostatics 2, the electric potential, again the electric potential and electric field and equipotential flux, then the equipotential surface, the uniform and non-uniform field and utilization factor, the electric field in free space, how it is behaved, the conductors and dielectrics, then dielectric polarization, then dielectric strength, the electric field in multiple dielectrics, and based on that the boundary conditions was developed. Here the electrostatics means mainly we are concentrating the permittivity, that is the epsilon, then Poisson's and Laplace equation and capacitance, energy density and its applications. So while we are comparing these two units, so we are concentrating the unit 1 and unit 2, that is the electrostatics. Here the first unit is mainly the basics and some theorems and applications we are going to discuss, but the second unit, the purely based on the capacitance calculations and energy density and its applications. Based on that, the boundary conditions, it is the major derivations we are going to derive it in the upcoming days. Then the unit 3, the magnetostatics. I lightly pointed out while we are discussing the objectives. The magnetostatics means energy stored in the magnetic fields. So the magnetostatics means the energy stored in the magnetic field, then the magnetic field intensity, and Biot law, Ampere circuit's law, then the magnetic field intensity due to the straight conductors and circular loop, infinite current and magnetic flux density, and the magnetic flux density in free space, conductors, magnetic materials, the dia, para, ferromagnetic materials and magnetization process, magnetic field in the multiple media, boundary conditions, the scalar and vector potential, Poisson's equations, magnetic force, torque, inductance, energy density and its applications, etc. While we concluding about magnetostatics, the magnetic field intensity and magnetic flux density calculation in the various topics, the various apparatus. It's a straight conductors, circular loop, infinite state current, etc. Then the magnetic material classification, dia, para and ferromagnetic materials. Based on that, the boundary conditions and scalar and vector potential we are going to discuss. Just the first two units were discussed in the electrostatics. It is here, there we are concentrated the permittivity, and here we are going to consider permeability. Then the while coming the fourth unit, the electrodynamic fields, that is the application oriented. It will include the both electric and magnetic fields. While we are passing the electricity in the particular coil, it will produce some induced EMF. Then induced EMF will form the rotating magnetic field and the fold formation. It will come, the fold formation or come under the category of magnetostatics. The electric field, while we are giving the supply, it will form some electric field. That's a field was created, that is the electrostatics character. Based on these three units, the earlier three units, the application oriented, that is the electrodynamic fields, the magnetic circuits, operations, that's the Faraday's law, and the transformer and motional EMF, displacement current, conduction current was missing here, but conduction current and displacement current we need to derive it based on that, the Maxwell equations, both differential and integral form we are going to derive it. Then the relationship between the field and circuit theory. The Maxwell's equation is the major derivations in this unit, because the Biot law, Faraday's law, Gauss law, based on that the four Maxwell's equations was developed in the electrodynamic fields. Then while we are coming in fifth unit, the electromagnetic waves, that's a wave, how the electromagnetic waves are generated. While we are in the first unit, the first topic, the sources and the effects of electromagnetic fields, there we are going to discuss what are the various sources are available to the electromagnetic fields. Here, what are the various sources are available in the electromagnetic wave generations, and how the equations was formed, what are the wave parameters are considered, what is the velocity and characteristics or intrinsic impedance, and what are the various propagation constants are considered, then waves, how it will behave in free space and lossless dielectrics, etc. Then the conductors, skin depth, whitening vector, plane wave, reflection and refraction, and standing wave and its applications. So this all we are going to study in the category of fifth unit. After completion of all units, we can ability to understand and apply the basic science and circuit theory, electromagnetic field theory, control theory, and apply them to the electrical engineering problems. The electromagnetic theory we can call as the circuit theory too, because already the second semester itself you was studied the circuit theory. We can say the advanced circuit theory or circuit theory 2, the name of in the name of electromagnetic theory. That's why the electromagnetic theory was both electrical and electronics engineers they are going to concentrate. Apart from that, it was very essential to solve the problem oriented skills, the mathematical derivations in the particular machines like DC motors, DC generator, and induction machines and transformers. The mathematical relationship was very essential based on the permittivity and permeability and magnetic properties, and conductor properties, conduction current and displacement current was the very essential for the designer. That way the subject is very helpful for the electrical engineering domain. We will discuss in the upcoming days. Thank you.